Alright, let's get it going. Sup, Tony and Saris. Starting my mental health downhill there, I fixed the title. Yeah, pretty much correct. Roggy Dev, what's up, man? So yeah, I'm gonna be working on my own game engine for once. Figured I'd do that since I really want to learn more about like graphics and rendering and everything that goes into it, instead of focusing on like an individual system like scripting or physics. Okay, I'm gonna disable those at some point, Tony. Although I do need to hydrate, to be honest. So yeah, I'm literally like setting it up from scratch right now. Like I don't have anything. So yeah, I'm gonna have a similar structure to, kind of similar base structure to Hazel, I think. Gonna be making some changes. For an example, I'm gonna be doing a slightly different structure, but obviously very inspired by Hazel, because that's the structure I'm used to. What I'm actually gonna go ahead and do is add the platform folder outside of the Fusion folder. Fusion is gonna be the name of the engine, because I like it. Fine, I guess I'll replace with Fusion. But yeah, I'm gonna be keeping the platform folder outside of the Fusion folder, because I basically want the Fusion folder to be all of the code that is not platform dependent. You should never, like any kind of client application should never have to include platform for most things. So yeah. And fun fact, I'm gonna be using Vulcan as the graphics API. So I'm gonna have to learn Vulcan. Window. Sure. So will we make scripting as the very first thing? No, never. I will have scripting, and it will be quite an interesting thing, because I think I'm gonna take a slightly different approach. No, I'm not gonna be using Lua, because screw that. I'm still gonna be using probably C#, although I may look into like C++ scripting. I would actually like to do visual scripting at some point, but that requires writing an entire compiler, and I'm not quite that insane yet. I should set up a precompiled header. Fusion, PCA, ooh. I want to make visual scripting that generates C# code. Well, I mean, you could just have it generate the actual IL code. So that's not, I don't think that would be too difficult necessarily. Although, yeah, it could probably turn out to be quite annoying to deal with. Yeah, precompiled header. Might as well get that done. Fusion PCH. You know what, Tony? That's not actually a bad idea. I mean, if you can make it generate C# code, making it generate something else should be pretty easy. Yeah, but like you don't actually have to make it generate like text. You can actually get it to generate the actual IL instructions. Don't need a flipping namespace for that. What do we need? We need string. I'm not going to include IO stream. Memory. It's going to be nice to have. Unordered map. Map. Vector. Make it generate. I think the source code could also be cool. Also make it generate visual nodes from C# source. Jesus, man. What else do I need? Streams. S stream. Sure, let's settle with that. Yeah, I'm gonna be doing Vulcan. But I need a basic architecture set up first. Can't have well, I could just straight up write a Vulcan renderer without having an engine architecture. But I do want an actual architecture set up first. But could you though? Okay, let's... PCH header. I don't remember what graphics code. Yeah, sure, definitely. I don't actually remember how. Okay. So the header, you just specify the actual name of it. You don't specify path, which is interesting. The source actually needs the full path or the relative path. Oi, I fixed that grid. Let's go ahead and regenerate that. Where am I? Here. Yep. Okay. Should now detect. Yep. Cool. Precompiled header set up. So let's get a window going. Windows window needs to include Fusion Core window. I'm wondering if I should do Fusion Windows. No, I'll just name the classes appropriately. Also, this is C++ 20. I figured I'd go for that immediately. I compiled my engine which uses Windows headers and D3D12 agility SDK in like 1 to 2 seconds. How many cores do your CPU has? E-man, what's up? Creator in Deep. I also started doing my own engine about 2 to 3 months ago. I develop it in my free time. I've been curious, do you have any good books, articles about game engine architectures? No, I haven't actually read any books or any real articles on architecture myself. I can recommend Cherno's videos. In terms of like the actual architecture, they're pretty good. So... sadly, I have not read any articles or books. No. Window properties. That's gonna have to be implemented. Eight cores and 16 threads, damn. The game engine architecture books are really good though, written by one of the main engine guys at Naughty Dog. Cool. Although, I don't know if I'm remembering incorrectly, but aren't Naughty Dog's kind of latest games kind of, you know, trash in terms of quality? I could be remembering incorrectly, obviously. Store the properties. Okay. Let's start with this. Whoops. Last of Us 2 is great in terms of graphics and engine work in general. Okay. Yeah. I'm probably remembering the wrong game. Because I'm thinking of... Is it Watch Dogs? Where you do... Like, you play as someone like a hacker or something. I may be getting Naughty Dogs confused with Watch Dogs. Or Watchdog or whatever it's called. Yeah, that's where I'm getting it confused. Pointer 56, what's up, man? Start this off with null pointer. Okay. Now, I need to look up... Well, no, technically, I think I remember... Right, and if this... So this returns what exactly? If it fails? Glfw if successful, false if never occurred. Okay. So if this is Glfw false, I'm gonna have to set up a search and things like that. Is Fusion just for fun? Well, sort of, but it's mainly because I want to learn more about graphics programming and a lot of different areas in game engine development. And it's also pretty much going to be a place where I can... Yeah, I know that you can do that as well, because it's 0, so that's a false value. But yeah, it's pretty much just for fun. I don't know. I'll be ugly for now, and just debug break. I'm gonna fix that, obviously, and I'm gonna not be doing this in the constructor eventually. When will Fusion eat Hazel? It's unlikely that it ever will. Okay, so if I want to set this up with Vulcan... I'm gonna have to define like glfw include none. And set the profile to be none, I think. Is it window attrib? No, I don't think so. All right, whatever. Let's. So I'm gonna be using vkdev.guide, thanks to implode. Glfw window hint, yeah. I haven't written like Glfw code in ages. Window hints, and it's Glfw. Okay, I'm just gonna look at the guide because I don't know if they actually do that. Glfw API, yeah, exactly. But they use SDL, not Glfw. All right, that's good. Just give me this code. All right. Believe it's Glfw include none. Nope, that's not it. HTML, Vulcan. Hazel 3D uses Glfw. Yes, you're using raw Win APIs. Damn. Of course, they link to that. Let's see creation hints. Client API. None. Glfw no API. I never touched Drawing API once, and it's enough for me to never do that again. Yeah, it can be painful to deal with that. Graphics constructor sets all the window hints before you init the context. Yeah, like that makes sense, but you also, because I think you have OpenGL in Hazard, right? So obviously there's some very different window hints at that point. Just use Vulcan. Okay, so I'm actually thinking if I'm gonna be using C-style costs or C++ style costs for this, because I do know a lot of people say you should only use C++ style costs. So yeah. Just do int properties with. Oh, is that considered valid? Like, because I know you can do it, but I do know that a lot of people hate it when you do C-style costs, and to me, this looks a lot like a C-style cost, even though it's just constructing. Because it's obviously creating a new int with this data. Oh, better bindless and the industry use API. Yeah. Can't know what you're missing out on if you've never done all of the APIs. It is valid even when using v4 in MSVC. Cool. I think I am. Let's check debug. No, maybe not. No, V3 or W3. But I am using conformance mode. And I'm gonna call this native window because reasons. Okay. C-style casts for the win. Yeah, like I use mainly C-style casts. Because I think 99% of the time I know that it is in fact a valid cast. So I don't really see like the big issue with it. To be honest, I should probably put this into like an init function. But whatever. And I don't think you do glfw make context current if you're using Vulcan, right? Yeah, exactly. So you don't do that. Good to know. This will do glfw poll events. Joy, the amount of clang tidy warnings I have enabled is probably not okay. Yeah, the context is only for OpenGL. Because with Vulcan you manually create the context using swap chains and devices and all of that kind of fun stuff. Okay. Cool. We need a way of telling if we should close the window for now, because that's eventually I imagine that will be an actual event. But for now, I'll just have it be a function. Okay, we have a basic thing there, so let's go ahead and include. Do I have Fusion as an include directory for our sandbox? No, I don't. Includers. Window. Okay. I don't think we have a way of actually creating it right now. We don't. I should use a unique pointer for this. How do you always start streaming without me seeing it? Because you aren't a real chat and have notifications turned on. Or it's just the fact that Twitch pushes notifications like 15 minutes too late. Also, I saw that Twitch recently changed their like VOD storage terms, so that if you're not an affiliate or a partner, you now only get a week of VOD storage instead of 2 weeks, which it used to be. Twitch pushes notifications with insane delay sometimes. Yeah, I know, it's terrible. And you don't have notifications on, so that definitely explains why you're always late, Marka. Fusion Sandbox app. TV2222 forever, what's up? And 8 Swaggy P, what's up? Need more water. Okay, so what's the problem here? Type name not allowed. What? Oh, I don't have memory included. It's whatever. So while not window should close. Obviously, this is gonna move into an entire into a separate application class eventually. All right, I think that should hopefully work, unless I've screwed something. Ah, what? Why am I including Glfw here? Emily, what's up? Yeah, committing mutiny. Poster check from Swaggy P. Okay, this should. Oh, good. Good. Huh. Oh, because it's trying to use Vulcan, I'm guessing. Glf, yeah, because it tries to find Glfw. Wait, what? Okay. That is internal.h. Next thing you know, Tim and Kareem split off as well and just be Jan and 0x in animation hell. I mean, to be fair, Kareem hasn't actually worked on Hazel in quite a while. Did you set up pre-make properly? What do you mean properly? Okay, so why doesn't it have... Okay, show... No, come on. Show all files. Oh, did I miss an include? How long before I gotta port Fusion to Linux? I'm gonna try and be good and make it as kind of portable as possible. And who knows, maybe I will go ahead and port it to Linux at some point. Made it include the correct GLFW headers and sources. Oh, that's what... Yeah, I don't think I did. Because I copied this pre-make almost exclusively from... almost exclusively from Hazel, but I used a new version of GLFW. Yeah, I always use VS Code for like pre-make stuff. Hello, I'm not making a game, I'm making a game engine. So, okay, there's plenty of files I have to include. Internal.h, for an example. Which is under source. Yep. Just sent you the one I use. Yeah, but I'm not gonna use that. It does look like it's very kind of portable, but let's see. Okay. So internal mappings, .h. Because I think these files got added after Jan forked glfw. So input, yep. Null underscore what? Platform. We don't have that. Platform.c. Okay. Hopefully that should work. Are you using the glfw fixes I made in my fork or still the broken pre-make? I did use your pre-make file, so that's all set up, but I haven't actually done the modifications to the glfw source code because I don't need that right now. Now you can have both X11 and Wayland enabled at the same time. Okay. Interesting. Let me just make sure I've saved. Reload. See, that's interesting. Glfw. Load module. Okay. What's the point of this file? Okay. So I assume I need that as well. What was it called? Null init. And do I need all of those null ones? Can I just do what you did and use a wildcard? Yeah, I can do that. Good. So that should get all of those. What's up, Igorzik? And I assume I need the Win32 module as well? Yep, I do. Presumably I need all of the Win32 stuff. And Tony just realized he's dumb. So, yeah, I should... Instead of doing all of this... I can just do that, I think. What? Did I forget a... Yes, I did. Fusion is my custom game engine that I just started working on. His attempt to undermine his boss. No, but like more experience is never a bad thing, so. And I want to learn graphics programming and all of that kind of stuff. And we now have a window. Whoop. Awesome. So, question is now, do I go straight for Vulcan and get some basic setup going there? Or do I do some more general engine architecture like event systems and that kind of stuff? Because I think Vulcan could be real interesting to just go at immediately. And like, obviously I'm gonna have to set up like an event system and that kind of stuff. To handle resizing and that kind of stuff. Okay, so Igorzik is saying Vulcan. And to be honest, I think I agree. Rugged Dev says Vulcan. Alright. So I'm gonna need to get the Vulcan SDK. Well, I have it. You have begun on the path of pain from Emily. Yeah. It's gonna be fun. So, okay. I have the Vulcan SDK installed. I have the environment variables set up. So you're making your own game engine. What can it do? Right now, create a window. That's it. I started it today. And obviously I want Fusion to be the only thing to actually, like, deal with Vulcan. Okay. I totally have not been stuck just abstracting an API that I have no knowledge of. Now you won't miss any progress. Yeah, hopefully not. I mean, I'm gonna be working on it like when I'm not streaming as well, but I'm only gonna be working on it during the weekends or during the like evenings. So, but you know, I'll try to stream as much of it as I can. Which points in here include. Okay, so it's literally that and include. Yeah, I'm gonna have to create the map first. Lib. Do you need the DLLs, or can you link statically to Vulcan? I imagine I need the DLLs, right? I can link statically, really? That's really cool. Can I ask you programming questions because you're way more experienced in programming? Yeah, sure. I'll answer them, assuming I know the answer. And Andres Python, thank you so much for following. Isn't simple event layer stack small functionality sounds more consistent right now? I mean, yeah, arguably you would think that I should do that first. But to be honest, I don't want to set up that yet because I don't need it at this point. I will set it up while I'm working on Vulcan because I'm gonna need it. But I really kind of want to get into Vulcan right away because that sounds painful and fun. All right, so I'm gonna need lib. Layer stack is unnecessary though. Yeah, like I can just literally write everything in Sandbox app right now. I mean, yeah, that it is a lot easier, but you know, I'm writing a game engine, and I kind of want to challenge myself, you know, do stuff that I don't normally do. So just link vulcan1.lib, right? That's all I have to do. Yeah, pretty much Necodroid. We have editor layer. Like, the thing is, the editor has one layer. And well, oh yeah, we do have an ImGUI layer. I forgot about that. Do I really need to be this? Whatever. It's all temporary. Vulcan1.lib. No, they haven't merged. But they do kind of very different things. ImGUI layer is literally just for setting up ImGUI to actually work. how do you program a file reader and a file saver for game engine? You mean as in save? I mean, you would probably use, assuming you're talking about like a regular way of reading and writing files on disk, and not like a special kind of save file thing. Just use S3 file system and like IOStream, that kind of stuff. Use the standard libraries methods for dealing with that, because it's a lot easier, at least initially. Yeah, but Agora 6 layers in Hazel, they're not layers that you would ever create. They're layers in the sense that it's just a way for the engine to communicate. It's a way for the engine systems to kind of communicate with like the editor or the runtime, right? So it's not something that, you know, you would have in C#. You would have a different kind of layer system if you wanted that in C#. Should be good, and put this under Windows only, because it's .lib, so it's libraries .vulcan, and let's include it as well. Okay, interesting. Reload that. Do I now have Vulcan? If I just go in here and include, I now have Vulcan. Okay, so I'm gonna be following the vkguide.dev initially, just so I can sort of get an understanding of how to set up Vulcan. Let's maybe take a look at this as well. Also streaming in... Nah, that I should be doing that. I mean, I think like I do have access to that. You can change the quality, although for some reason Twitch doesn't provide a 1080p option if you stream at... Yeah, I know they use VK Bootstrap. Implode told me that. So I might use... I might reference like Vulcan Guide, or whatever it's called, for kind of just the initial code. But yeah, it's weird because Twitch doesn't offer a 1080p option if you stream at 1440p. They only offer 1440p, 720p, and anything below that, which is weird. Building project. Okay, so include that. Yep. Oh, and it uses CMake. VK types. Okay, interesting. Well, if I stream at 1080p, you can still select 720. Because I'm actually streaming at 1440p, so I'm streaming it higher. But you can, because I'm an affiliate, you can change the quality. Okay, so you create a VK extent. Tell you what, let's use Vulcan tutorial initially, because at least for like the setup stuff, because if I understand it correctly, VK Bootstrap basically just abstracts away the majority of the initialization code, and I do actually want to know kind of how that works underneath. Please don't write engine in C++, I only know Python. There's no point in writing a game engine in Python, in my opinion. It's not fast enough to deal with the kind of low-level stuff that a game engine needs to deal with. C or C++, maybe Rust. It's fine for that. So create a window, yep. Destroy a window, that's fine. Does this explain what a VK extent is? Because I think it just holds like width and height. Or, yeah, pretty much. But it doesn't explain it, so. Well, C#, maybe Java, it's doubtful. Yeah, it's a vec2. Okay. Initializing Vulcan, let's take a look. And I may have to use YC++ but not Rust. I don't know Rust. That's why. I'm nothing against Rust, but I don't know how to program in it. So why would I switch? C++ has been working just fine. Direct control initialize, yep. VK instance and VK device, and I believe a VK device is basically a reference to the actual GPU, and a VK instance is effectively the driver, if I'm not incorrect. Like, I know device is the GPU, it's the physical device. No global state, yep. That's good. We're going to link to, okay. You can load them manually. Yep. VK instance. Vulcan API context. Okay, it's not necessarily the driver. It's a connection to the driver, yeah. Oh, okay, so there is a VK physical device as well. VK device is basically a connection to that device. Okay. Got it. That makes sense. Steve to Andy. I also tried to make a game engine. Would it be a good idea to use my own programming language or graphics API? Sure, why not? I mean, it's probably not going to be mainstream. Well, I mean, it's an engine, so we would abstract away all of the things. Okay, so you need that stuff. I should probably use this initially because this actually uses Glfw. And I'm going to be skimming past a lot of this because I do know some of the basics. If you want to make it in C#, make it in C#. An instance is created by setting up the API through a VK instance. Describe your application, extensions, that kind of stuff. Yep, I remember that part. You can query for Vulcan supported hardware. Select one or more physical devices. Okay. Logical device and queue families. Okay. Queues are allocated from queue families and they support a specific set of operations. Yes, I did do a posture check. It's just that my posture is not that bad right now. There. Straight back. Lumbar supported. All of that stuff. Okay. Yep. Image views and frame buffer. So image views I don't know that much about. We have to wrap it into an image view, so it's a VK frame buffer. References a specific part of an image to be used. No frame buffer references image views that are to be used for color depth and stencil targets. Cool. Stretch from Agorsic. Thank you. Okay. Guess there could be many different images in the swap chain. We'll preemptively create an image view and a frame buffer for each of them. Makes sense. The moment you play games and computers like normal. Okay. That sounds good, Tony. Render pass. Type of images that are used during rendering operations, how they will be used, and how their contents should be treated. Single image as color target. Yep. Cool. Creator in Deep, thank you so much for following. Okay, yeah, I do recognize you do create info stuff, fill some structures. Validation layer is going to be very useful, but let's get going. Yeah, go away. Okay. So no API yet. We need to enumerate the instance extensions properties, sure, to get the number of extensions we support. Tell you what, let's actually do that right now. Really should have set up some logging, but whatever, let's include IOStream here for now. Don't they want me to include Vulcan before Glfw? I don't know, we'll see. Vulcan. I knew some OpenGL prior to starting to learn Vulcan, but not much, only from Chern's videos. People said Vulcan is really hard and so on, but after 1 month of learning Vulcan, it wasn't as hard as people said it was. I think a lot of people believe that Vulcan is very difficult to learn because it's a lot more verbose. But to me, it makes a lot of sense. Aiden, what's up? Also, I need to get something to block up. I have a window right there, and during the evening the sun just kills my eyes. I assume I can just pause null pointer. Yeah, and this should get me the number of extensions that my GPU supports, sort of. Let's see if, because I don't think I'm linking statically to Vulcan, or maybe I am. Yep, static by default, I guess, or maybe it just knows where to find it. 16 extensions, good, we have Vulcan. You work on 2 engines at the same time. Isn't this conflict of interest? I don't know. Maybe Jan will consider it a conflict of interest. But I mean, I think he'll be happy about it because I am kind of learning more, getting more experience, and I'll be able to write better code for Hazel. Don't need to do that. I've already set it up. Don't have GLM. Gonna need to get that at some point. Okay. Right, so okay. C++ is possible to form automatic resource manager using RAI. Yep, that's very clever to do. Smart pointers works as well. Explicit about allocation and deallocation. Yeah, we're gonna use VMA at some point. Okay, yep. P allocator. It's an optional parameter that allows you to specify callbacks. So I think with VMA you would actually put something into P allocator. I don't want Glfw to include Vulcan. How much experience do you have with C++? Professionally or just in general? I have some weird issues with VMA where it says that I freed 9 gigs of VRAM, whereas I only have 4 gigs. Cool. Love those kinds of errors. Yep, already have it created. Okay. Now the question is, I would probably want to create some kind of Vulcan context in general. So I have, hang on. It's 20. I think I started working on Hazel in 2020 or beginning of 2021. But I think it's like 3 years kind of real experience. Flate, what's up? But I've kind of been playing around with C++ for 5 years, but I didn't start taking it seriously until 2018, 2019, I think. Okay, so I'm gonna have, so I assume this is sort of similar to context initialization. So you initialize it by creating an instance, so that would probably be Vulcan tutorial is giving me violent flashbacks. Yeah, I'm not going to be using it for the entire time, but it does use glfw, and it doesn't use VK Bootstrap. So yeah, so what I'm gonna do under platform, Vulcan. Let's create a Vulcan context file. And I think initially I'm gonna be not very kind of good at abstracting this away. Yeah, I'm gonna be using VK guide as well. I'm really only gonna be using Vulcan tutorial for the initial setup. Okay, so we'll have a constructor here. We'll have a destructor. Let's start with that and we'll see what we need after that. So in Vulcan context, I'm gonna include Vulcan. Should probably put that into the PCH, but whatever. And we need a VK instance. Let's call it instance. And this is the kind of actual Vulcan API interface as far as I understand it. So we need to create an application info with some basic data. We need to create a create info. Okay. And we need to get the Glfw extensions, so we're gonna need the window. Let's start with this. Application info. Right, it's gonna be fun with the whole S-type business. Structure type application info. Fusion, Vulcan, app, whatever. The version, the engine name, the engine version, and the API version. And I don't think these matter too much in general. To be honest, Vulcan is very well designed. All the structures also much flexibility for the long run. Yeah, definitely. It's very flexible. Deprecated. Okay, so use this one instead. Variant. I don't understand what it wants me to do, because here it says that VK version is deprecated and it says to use this one. Here it says that this one is, and you should use that. So what's a variant? Probably for safety critical or normal. Okay. Let's take a look at this. It's the variant number. Yeah, thanks. So they use 0 here for like the header version. Did you look into Bazel as a build system? Nope. VK. I mean, this is the application version though. It's not the Vulcan version, right? So it kind of wants me to make the version. All right, whatever. You know what? Let's do that for now. It's not important enough to be for me to bother with it. Fusion. Engine version, whatever. Let's call that 1.0 as well. Cool. Yeah, application version, yeah. Only matters for driver issued optimizations. Goddamn. Okay, I'm gonna have to sit back a bit because the sun is blinding me. Only matters for driver issued optimizations. Okay. So it doesn't actually matter. What about application name and engine name? Do those matter? and API version. Now, which only for driver related things. Okay. So it's not actually important. Now, as for the API version 1.0, you saying I don't matter, implode? Yeah, no, but I get what I get what you're saying. Let's use 1.2. I'm not gonna do 1.3 because I don't use it. So yeah, let's go with 1.2. Okay. VK instance create info. Yep. Instance create info. And this is where I'm gonna need Vulcan. Doom3.exe. You will use 1.3 unless you want to suffer through render passes. I want to suffer through render passes because I want to understand render passes. See? Okay. Specify the desired global extensions. You don't need render passes on desktop because there are hooks. Yeah, but I still want to like understand how Vulcan, how render passes are supposed to work, at least from an API point of view. Okay, so we need the required Glfw extensions. Let's do something bad here. Do this. And obviously this isn't great. We shouldn't tie the Vulcan context to Glfw specifically, but for now, Glfw get required instance extension. Okay. Enable extension count, yep. Okay, and then we need to create it. I just checked and know when I changed it, but I'm apparently using 1.3 in my engine. Yeah. Hazel supports 1.2, and interestingly enough, we don't use any 1.3 features. Even though Karim basically decided that we were gonna limit the engine to 1.3. So, yeah, that's not equal to success. Debug break, need asserts. Okay, good. So we fill out some data. get the required Glfw extensions or instance extensions, and we create the actual interface for the API. Okay, cool. Okay. You wanted to use 1.3, but people aren't able to update their drivers. Yeah. That was fun. I think I spent about 2 weeks literally just telling people to update their drivers or telling them that their GPU is trash because it's like 15 years old and doesn't work with Vulcan at all. So yeah. Yeah, I don't use macOS. If you look at, you'll see that one of the possible error codes is extension not present. We could simply specify the extensions we require and terminate if that error code comes back. Okay. Optional functionality. Don't think I actually need that right now. I don't need any optional extensions as far as I know, but might be good to do. And then we need to destroy the instance. Okay. Should probably verify that this will actually run. So, you want to handle all that optional functionality with profiles anyways later on down. Yeah. Yeah, because like that's obviously something that we want to handle in a good way. And I'm eventually going to create like an abstraction of the kind of graphics context. Get out of here. But for now, I'm just going to do static. Let's do unique pointer for now. It's going to change. Don't worry. S Vulcan, except that will construct it immediately, which isn't great. So let's not have it be static. Except, yeah, you see this problem. No, it's not, because that won't construct it because it's a unique pointer. The hell am I doing? Okay. So I literally just want to step through this and check that it doesn't crash. Obviously, it's not a lot of code. 2. Okay, so it initialized correctly. Awesome. Swaggy P redeemed hydrates. I will. Just need to grab some more water. Because this bottle doesn't hold much. Okay. So that's it for setting up the instance. Okay, I understand that. Let's maybe also go and print the extension. I see the first one was like the surface extension, but need to set up proper logging as well, because including IOStream everywhere is not good. Literally just want to see the other extension here. Win32 surface. Okay. So those are kind of the required extensions. Good. Eventually we may want to pass in a list of extensions here. I can see that being a thing we want. Okay, so validation layers, yeah, that could be good to kind of get set up. Although I think I'm currently linking against the release version of Vulcan, or maybe I need to link against some of the other stuff, like VK layer utils. Yeah, there's no debug version of Vulcan here that I can see. So, okay, cool. Explicit about everything, yep. Validation layers. Checking values of parameters. Okay. So you need to say that you want the validation layers. Is that an extension? No, it's okay. Cool. What's the difference between layers and extensions? Or is this literally just for validation layers? Okay. So we need to determine if we want to enable validation layers. So let's do if def fusion debug. Layers are callbacks for any Vulcan function that gets inserted. Okay. Doesn't really need to be constant expression. It can just be const. How many years of C++ are required to create a rendering engine? I have no idea. I imagine you could do it with less than a year's experience, but it would be pretty painful, pretty hard at least, I can imagine. Okay, and extensions are additional functionality like new functions. Got it. Validation layers. True. We could obviously use like constant expression if checks. Is it useful to build a game engine first? I don't think so. Like if you're building a game engine yourself, you probably want to be able to render something. But of course, like, you can learn as you go. That's what I'm doing right now. But that's mainly because I, like, already know quite a few other kind of systems in game engines. What is this song? It's like 45 seconds of silence. Garbage. Okay, so we have that. We need to define our validation layers. I don't need to use a vector though. I can just use a C. I could use std array. But I think doing a const don't they have like defines for these that I can use instead? I want to create my own render engine for software like Blender, or render engine like Cycles or Arnold. Ah, okay. So an offline rendering engine. Yeah, I'd recommend learning C++ before you try and do that, to be honest. For layers, no. For extensions, yes. Okay. Good to know. Boney Montana, thank you so much for following. Okay. So check validation layer support. Would be good to do that. And after how many, I don't know, you definitely want to learn C++. Like, you want to be comfortable with it, and you need to be able to you need to have a good understanding of it before you start writing any kind of complex software. Good evening from the continent. Which continent? There are 7 continents out there. I mean the US? Okay, let's have a check. Europe. Oh, cool. Belgium. Awesome. Do you recommend me doing it with Vulcan, OpenGL, or even DirectX, and why? Well, I don't recommend OpenGL because it's an outdated API. Vulcan or DirectX. But definitely have a good understanding of C++ before then. Because C++ is, I don't know, it's not complicated, but there's a lot that you need to understand about it. And DirectX and Vulkan, yeah, it's just so much to learn. Okay, so enumerate the instance layer properties again to get the layer count. Then we get the layer properties themselves. Just I hate the fact that you lot found the fact that we have a hydrate redemption or a hydrate reward. You're drinking the shower. No, I don't. Okay, so we get the layers. We go through all of our expected validation layers. We go through all of those and compare them and say, did we find it? Okay. No, I'm not insane. Well, might be if you keep trying to drown me. And you start initializing your variables, man. Goddamn. I thought it actually guessed the function I wanted. Okay, so it takes the town and any potential properties. Did you know Brandon Gale is Vulcan engine series? No, I actually haven't heard of that. Okay, so is this better what they're doing? Just actually allocating the right amount of memory once instead of... Well, yeah, because I don't think this will... Yeah, we kind of have to do that. Layer properties and their pointers or no pointers? No pointers. Supported layers. Which constructor will this use? It will use... Not that one. It will use that one. Sure. Let me just copy that link. So I can have it for later. There we go. Okay, so we have that. And then we loop through all of our validation layers, go through those, try to find it. Requested layer name. Sure. Then we go through I don't know, just call it layer in supported layers. If right, string compare layer dot layer name, and if that is equal to 0, right? Yeah. Break out of the inner loop. If not found layer, return false. Otherwise, return true. Cool. We now have that. If we want to enable them and we don't have support, we have an error, obviously. Now, arguably, this is something I can just check at compile time. Right? Now, I know C++ C++20 has something like const eval, which does what exactly? What's the difference between that, like that, and const expression? Obviously, this isn't something that's super important, but so is this like a stricter version of const expression? Okay, yeah. So, okay, yeah. I think I understand what the purpose of it is. Because const expression doesn't necessarily mean it's evaluated at compile time. It can be evaluated at runtime if necessary. But I guess that's not the case with const eval. But doesn't really matter either for this. Yeah, now we need to actually go ahead and do if c enable validation layers. Right, one problem with using const char array like this, we can't use size. So fine, we'll do this. Whatever. Enabled layer count, which is uint32t. Daniel K, why not std array for layers? So I don't really know if this is the case, but I imagine we may want to kind of automatically determine layers based on certain parameters. So we may want to be able to modify this at runtime, but I'm not sure about that, because I haven't used this before, so I could be completely wrong about that. You maybe want to actually just always have them defined here. No clue. Okay. Now they did have some check if, yeah, because we do need to check for support. You only need one layer name for validation layers. Yeah, but there are other layers, right? So we may want those at some point. Okay, let's run it. See if it works. It should. So we do have all of the layers. Go through this. We get that. Do that. That took a while. But I guess we are in debug mode. And with validation layers, I imagine, slow things down. Okay, cool. I like it. So we need a callback, right? Yeah. Just place a callback in our program. This will also allow you to decide which kind of messages you would like to see, because not all necessarily fatal errors. If you don't want to do that right now, you may skip to the last section in this chapter. Yeah, I think I want to set that up right away. But before I do that, I'm gonna head to the bathroom real quick. So once again, I have a starting soon screen because I don't have a break screen. There we go. Actually, I don't think I'm gonna do this right now. Like, because I'm fine with them printing to the standard output by default. At least initially. I kind of want to get going with this. Okay, so let's move on to physical devices and Q families. Let's actually maybe reference this guide for that. See what they have to say about it. So we need a physical device, we need a device, we need a surface. Okay. Cool. Uh-huh. I can see why people would want to use VK Bootstrap. If it's this simple. God, don't remind me of the mess that is my Vulcan stuff. I can see why people like VK Bootstrap. I'm definitely gonna use that eventually but for now I just want to know like this stuff, so I guess I'll stick with this guide for now. So okay, pick physical device. This object will be implicitly destroyed when VK instance is destroyed, okay? So arguably that belongs to the context as well. Physical device. VK physics, yes. Physical device. Let's also get VK device going here. Call it logical device or whatever. So picking the graphics card to use. Preferably we want to use a dedicated GPU. Okay. Set up physical device. So we need to get all like the number of physical devices. Physical device count. VK enumerate physical devices. Needs the instance. Yep. Let's just run this and see what it says, because I think it should say like one or two, because I have like an integrated GPU in like as part of the CPU. No, apparently I don't. I guess I only have a dedicated GPU. Cool. So, I mean, I don't see how. I mean, okay, so it would probably be 0 if you don't have a GPU that supports Vulcan, I can imagine. Accessible to a Vulcan instance, yeah. So obviously if you don't have a GPU that supports Vulcan, yeah, screwed. Okay. So realistically, we should be handling this as well. Now, I did see this defines some kind of somewhere. Yeah, exactly, they did this. I'll deal with that at some point. Okay, so we grab them, and then we need to actually grab references to all of them. To do physical device, physical devices. Is device suitable? Yeah. This music truly reflects the tone of selecting a physical device. Yeah. I think it's like the Epic Mood playlist. Yeah, it's the Epic Mood playlist on Epidemic Sound. Okay, so we want to select a device. How the hell? Like, what are some good kind of metrics to use when selecting? Obviously, we want it to be dedicated if possible, but you know, so we want to prefer those. Need to make sure, presumably, that it supports the necessary queues and all of that kind of stuff. Feature support and everything. Right. So let's go through. All of the devices. Device in physical devices. And then we need to check if it's suitable or not. So we need to get the device properties. Which I assume just holds a ton of data about the actual device. Features, okay. Device properties. Also, I noticed we have a different one here. So do you need to use like the function that's called that has 2 at the end if you want like 1.2, or what's that for? Yes, useful. Emily redeemed stretch. Okay. Thank you. So, okay, I don't understand the point of it, so I'm not gonna use it. I probably don't even need it right now. Again? Sorry about that. And we need to get the physical device features as well, okay? Device features. 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 Okay. Let's actually have a look at what. So API version, so I guess that's the supported API version. Maybe. That's the vendor ID, device type, which I imagine we're interested in. The name. Okay, sure. Limits and other stuff. And features has what exactly? A lot of stuff. Okay. Yeah. So this actually checks proper feature support. So geometry shader support, okay. 64-bit floats. I won't pretend to understand half of that, but I understand some of it. Supported Vulcan version, yeah, okay. Texture compression, okay. There are more details that can compare from devices. Yeah, I figured. Dedicated graphics cards that support geometry shaders. So you do device type equals discrete and that. Okay. Give them a score and pick the highest one. Yeah. That sounds like a decent idea, to be honest, but I think for now I'm just gonna pick dedicated. Application function. Okay, yeah. Understood. So for an example, because we're gonna have to check Q families to determine if we can actually use the device, right? Yeah. We're gonna have to check that it has the necessary Q families. But like, we could start by saying, you know, if device, it's not a pointer, stop. What? This isn't a pointer as far as I know, like not a raw pointer at least. So why are you trying to do... Why won't you give me auto completion? Oh, wait. That's what I wanted. So we could check device type. Right? So integrated, discrete, virtual. So I'm gonna say integrated and discrete will support for now. So if it's not equal to discrete and it's not equal to integrated. Well, to be honest, like I can't even test integrated GPUs because I don't have one. So discrete means like a dedicated one, right? So an actual graphics card. As opposed to a separate processor connected to OSVN interlink, yeah. Let's continue. And we need to check Q families. So we do need to go through and actually find all of them, like the necessary one. Right. That sounds mildly painful. I mean, I could say that for now I'm not gonna bother with it, but like because I know mine. Well, no, actually, I do need to check Q families because I imagine one GPU can have multiple Q families. Definitely capable of having multiple Q families because I think like actual graphics is one Q family, have compute, and a bunch of other stuff. So we're gonna have to check for that. Great. Okay. What would a good way be of doing that? I think for now, what I'm gonna do is I'm gonna have a Boolean, a function or method. Has required Q families. And I'm basically just gonna check. But I think do we need to get the actual index or like ID of the Q family for it? I assume we do need that. Yeah, I think we do. Q. Family. Indices? Yeah. And he has that as an optional. To check if it has a value, but we could just say give it an invalid value otherwise. I assume 0 is a valid Q family index. Probably is. I don't like using optional. Use size max or something. Yeah, I could do that. Just give it a bunch of Fs. But yeah, sure, let's use that. Graphics family. Sure. This is obviously gonna move into some other place, I think. Do you have a job? Yes. My job is to work on a Hazel, the game engine. Which is still weird to say. Get you families for a VK physical device. Your job is to break it. No, that's your job. Well, no, rather, that's Tim's job. Q family indices. Return Q family indices. But yeah, so I am professional game engine developer. Somehow. I actually quit my job of making stuff not work. That's a lie. No, but like, to be fair, you have managed to get stuff. You're learning Vulcan. Yes, I am. Break it and bring it into place it's not supposed to be. That's true. Okay. Yes, so I decided to learn Vulcan. Because why not? Q family count? Yes. Q family count. And I assume it's VK. Oh, get physical device. Okay, so general convention seems to be if you want to get something from a physical device, you call it get physical device, something else. Q family properties, I suspect. Device count null pointer. Same sort of deal here. Yeah. I'm noticing a trend, I'll say. VK. What's the actual type? Come on, show me the type. Q family properties. Q families. Q family count. And then we need to loop through them and check if they have the necessary bits. The necessary Q family, I guess. Trade offer, I get your soul and you get Vulcan knowledge. Sounds almost worth it. Okay, so we do that. Yes. Why aren't they just using a normal for loop? If Q family. Is it flags? Yes. and VK Q family or Q graphics bit. Graphics family equals I. You don't need to do that manually. You can just use a normal for loop or range base. No, this is range based for loop, sorry. Okay. So we grab that, we check if it has the graphics family. If it does, we are Gucci. So device, and if graphics family, if it's equal to uint 32 max, we continue. Nice, nice. Create a... Oh. And if we get here, we know that this is the device we want. Physical device equals device, and break just to be safe. Because if we'll use the first one we find that matches all of these properties. I'm fine with that. Okay, and then we need the logical device. Set up logical device. Fun. I imagine it's going to be somewhat similar. Maybe a bit simpler. So it's VK device, yeah. I already added that. So, after selecting physical device use, we need to set up a logical device interface with it. Okay. Describes the features we want to use. Understandable. Also need to specify which queues to create now that we've queried which queue families are available. You can even create multiple logical devices from the same physical device if you have varying requirements. Okay. Specifying the queues. Right. Yeah. Okay. So we'll do this. Queue device queue creation info. Create info. This is the graphics queue, I believe. Graphics queue create info. Device queue create info. We need to tell it the queue family index. Graphics family. Queue count 1. Allow you to create a small number of queues for each queue family, and you don't really need more than 1. Okay, that's because you can create all of the command buffers on multiple threads and then submit them all at once on the main thread with a single low overhead call. Yeah, sandbox app.cpp isn't in the engine project. It's in the not for me, but I do know that. So if you've been following Jan's tutorials, obviously you'll have that. Yeah. But I'm not following his tutorial. Time to get some eat. Yeah, sounds good, Tony. Oh, now I want noodles. I have some, I could make some, but I'm not gonna do that right now. Okay, so Vulcan lets you assign priorities to queues to influence the scheduling of command buffer execution using floating point numbers between 0 and 1. This is required even if there's only a single queue, so I guess it doesn't really matter, but I guess you have to do it either way. The next information to specify is the set of device features that we'll be using. These are the features that we create support for with... Okay. Cool. We can simply define it and leave everything to VK false. We'll come back to the structure once we're about to start doing more interesting things with Vulcan, like compute shaders and what was it called? Geometry shaders. So it's a physical device features. Physical device features. Device features. Features. Right, yeah, and we can just set anything we want to be true if we need it. Good to know. So far, I'm keeping up, I think. Creating the logical device. Pretty much what I expect. So VK device create info. Device create info. Set the type. Looks very similar to the instance create info in terms of what it actually contains. Queue create infos, okay. Mendoza, what's up? Graphics queue create info. Yeah, I don't have a language command. Do you mean like this? Because this is C++. Queue create info count. Yeah, it's C++. People like to watch you suffer, apparently. Yeah, it's always these streams when I'm gonna be suffering that people watch, which is interesting. We only have one right now. Enable features, right. Device features. It's gonna be nothing. Mendoza, thank you so much for the follow. Who doesn't? Yeah, that's true. The remainder of the information bears a resemblance to instance create info. Yep, definitely. Requires you to specify extensions, validation layers. The differences, these are device specific. Okay. Less people show up to watch me, therefore I must suffer less. It just takes time for people to find it. Like usually I only have like between 6 and 12 viewers. Except during Let 'em Dare. During Let 'em Dare I had like 200. Yeah, it's super fun to be on. Like you don't even have to have a lot of viewers, because it's just fun to stream. Makes you actually work instead of just procrastinating like Tony. Okay, an example of device-specific extension is the swap chain. Interesting that that is an extension, but I guess it's you don't actually require a swap chain at all times. because you may not actually need to present stuff. You could only be doing computing. Previous implementation of Vulcan had made a distinction between instance and device-specific validation layers, but this is no longer the case. It's not. Yeah, but this is 1.3 though. Oh, wait, what? When was this changed? Isn't there another LD in the fall season? Yeah, it's at the end of September. I believe it's September 30th for me. And we are definitely going to be participating. So, yeah, I should stream making Hazard if more suffering equals more viewer. I would have 50k people watching. Yeah, definitely. Previous implementation of Vulcan made it. Yeah, okay. So they're ignored by up-to-date implementations. I don't know. Hydrate. God damn it, Tony. But yeah, Studio Journal will be participating in LD51. So it's a good idea to still set them. Okay, fine, I'll do it. Where do we have that crap? Up here. So let's do it for this as well. Cool. Too bad there isn't a category for man screams at electric books. 1 second. Goddamn. My cat decided to jump up on the bench in the kitchen. Don't actually know what it's called. So, okay, we do that. And then we create the device. Simple as that. Cat stream. Create device. So it needs the physical device. It needs the create info. Won't be passing an allocator. And it needs to know where to put the device. And if that is not equal to VK success. Success. Thank you. We simply do a debug break. Fail, I guess. For now. Don't really care. Yeah, go and eat something, Tony. And then we need to destroy the device. Presumably before we destroy the instance. Device. And the allocator, of course. Okay. I'm actually liking this so far. Everything makes sense. I'm waiting for the hell to begin. Okay, and then we need to actually retrieve the queue. We don't have a handle to interface with them yet. First, add a class member to store a handle to the queue. They're implicitly clean up when the device is destroyed, so we don't need to do anything in cleanup. We can use get device queue, give it the actual one that we want there. Interesting, interesting. Don't know if all of this actually belongs in get device queue. I don't know if all of this actually belongs in the context. I don't think so, but it's a nice place to put things. Queue family indices, graphics family, the queue index, which is 0, and put the queue there. I assume this can return, that returns nothing. Okay. Everything makes sense until we press the compile button. Oh yeah, I haven't actually compiled since I wrote this code. I trust it. With the logical device and queue handles, we can now actually start using the graphics card to do things. Yes, but I want to make sure that this actually works before I do that. It's always good to test your code regularly. That looks like bullshit to me. What? What is this character? God damn, I have a lot of windows open. Okay. My delete key was doing nothing. So where did I mess that up? That is for... is this engine going to be open source? Yep. I plan on having it open source. But it's not available, like I haven't actually pushed anything to GitHub. And the repository is currently private because I do want to protect the branch so people don't randomly commit to the main branch. Although I don't think that's going to be a problem, to be honest. But yep, it's going to be open source under the GPL 3 license. Judy calls around the house. I'll see you later if you're still online. Yep, have a good one, Emily. So that is for the actual Fusion project. What? Where did I do a typo? That is definitely a typo. Should be there, there, there. Yep, good. Make sure I've saved everything, regenerate the project, reload. Thanks. Delete that. Delete that. Let's do a fresh build. Do a fresh build. My cats are going insane for some reason. Alright, whatever. Good, that built. So let's put a breakpoint here and step through the code. Make sure it works. Physical device count is 1. We grab them. We go through them. We get the properties. It's a discrete GPU. Okay, RTX 3070. Yep, that's correct. Has some limits and stuff like that. Cool, cool. Device features. Doesn't have some texture compression options, but it has pretty much everything else. Yeah, it's just some texture compression options that are missing. 0. Okay, that's valid. We set the physical device. We break out of the loop. Grab those again. We go through and we create these boys. To get the logical device. And this should have everything set to 0. Do that to be safe. Create the device. That succeeded. We get the device queue. Or the graphics queue. That looks fine to me. So let's close this. Check no validation errors. Good. We close that and we shut down. Hey, it works. We actually have everything set up. Or, well, we have the context initialized. We don't have everything set up. Should make that in null handle, just in case. Awesome. Surface, yeah. Let's check. Device, and then swap chain. What about the surface? Null handle is type def to null pointer. Yeah. I imagine it is. Well, it's defined to null pointer, but honestly, I think specifically using this can be good because it indicates that this is just a handle, not an actual real thing that you should be dealing with. Because they're all handles, so why not use null handle? Okay, I mean, it's great that they want to create a swap chain, but I don't see where they use... where they actually do the surface. Okay, so that's done as part of VK Bootstrap as well. Okay. Yeah, it's kind of sad that they use VK Bootstrap for a beginner tutorial. Just completed the whole Vulcan tutorial, and I gotta say, there's no way I'll remember the code. The only part I remember so far is to create an instance with VK create instance and VK begin render pass. Yeah, it's a lot of code, but I mean, you don't need to necessarily remember everything. And if you work with it, come on, Marka. I need to get stuff done. Hydration is key to a successful life. You're not wrong. Like I say though, their validation layer for debugging is so useful. Yeah. And I do like the fact that they actually have it as an extension, so you're not required to use it, and it's not always there. Yeah, you only write the initialization code once. Okay, so we need a surface. And I think it makes... I don't know, context maybe shouldn't have the surface. Maybe that should be in the swap chain. Well, no, because the swap chain isn't... A surface isn't owned by a swap chain. It should realistically be owned by the context. Because everything should be drawing to the same surface, I think. And Obi, thank you so much for following. And Hydrate, of course. Thank you, Swaggy. Okay, so VK surface KHR surface. That also just a handle. So that comes from non-dispatchable handle. No idea what that is. You don't need to worry about the layers. You can load them by environment variable or via Vulcan configurator. And I need running low on battery. I never bother with them in my code anymore. Yeah, it's fine though. I kind of like having everything kind of done by my code. I'm not opposed to using third-party tools or external tools. They can be very useful. But if I have the option of doing something in engine, I think that's what I want. Okay, set up surface. And I think that's the kind of last bit of context setup I have to do. Glfw, thank you so much for following. So, a surface is the surface that we draw to, I suppose. Or I'm guessing. Platform agnostic cannot interface directly with the Windows system on its own, makes sense, yep. We need to establish a connection between Vulcan and the Windows system. We need to use the Windows system integration extensions, which is KHR surface. Yep. Extension is an instance level. Okay, good, good. What's up, Tony? No, the surface is the thing you throw out the window. The Windows surface needs to be created right after instance creation because it can actually influence the physical device selection. Yeah, okay. That makes sense. I have added the last few layers to vertex back in, but the compiler and transpilers don't do anything as of right now. Awesome. Okay, so we actually need to create this before, so not here. It needs to be after we initialize the instance. So right after this, we need to actually set up surface. Platform agnostic creation isn't because it depends on the Windows system details. Oh, right, yeah. Also, I will eventually switch to using Win32 API for window creation because I do want to maybe support Direct 3D at some point. Glfw, I'm literally just using that because it's easy and quick to set up. And to be honest, I'm probably going to switch to the Win32 API pretty soon. Because obviously this kind of needs it. It needs the Win32 API in some way. So okay, right, we're gonna need to actually define, what was it, expose native Win32, expose native Win32, and remember to include glfw3 native. Now it also wants me to define VKU's platform Win32 KHR. Is that something that's going to be used by glfw or Vulcan? I'm almost thinking this is a glfw thing, but entire solution. That is an actual Vulcan thing, which includes that. Okay. Right. So VK Win32 surface create info KHR. Yes. Vertex go yes. Peter goes no. Nah, I'm always yes. Win32 surface create info. Yeah, I'm gonna need a good system for abstracting this in a platform agnostic way. I could really just do ifdef fusion platform Windows, to be honest. And I'm probably gonna have to. But yeah, VK structure type Win32 surface. Yep, that. Very, very verbose. And we need the hwin and the h instance. What was it? Get glfw get. Okay, yeah. Win32 window, and it needs the window. Yeah, makes sense, and I think it makes a lot of sense that we need to include the window in here. Let's not include. Yes, I almost typed Hazel. Let's not include Windows window. Let's include the actual platform. Include failure.h. Nah. Window comes with a reference or a pointer. Because if it's a pointer, we can just pause this. Yeah, so let's do const window pointer window. There, we're gonna have to add a virtual void pointer get native window const that. Then the h instance equals get, what is it, module handle. For now, I'm just gonna do this. Let's go with that. VK create Win32 surface KHR for the instance surface creation detail, custom allocators, variable that surface element stored in. Actually, you need to use hazard. No, because last time I tried to use hazard, it didn't compile. Despite both you and me using Windows. So, no. Right. If VK no. Alright, VK create Win32 surface KHR instance. That's null pointer surface not equals VK success. Return. Danny Bmax just got here. Is there any reason why you don't create the Vulcan Windows surface through Glfw using Glfw create Windows surface? I did not know that was a thing. Glfw create Windows surface. Oh my god. Thank you so much. I did not know that was a thing. That basically does... Damn. I appreciate that. So it needs the instance, needs the Glfw window. Allocator, I don't use one. That just made my life a lot easier. Let's do this. Surface result. Because I don't want it to be an absolutely ginormous line. Thank you so much, Danny. That made my life a hell of a lot easier. Which technically means that this works for other stuff than just Windows. Which is nice. Yeah, it's a lot less verbose. Do I still need this, though? To do that? Because this is... No, I shouldn't need that. Right? It's in Vulcan.c. which I may need it because I have it set up so Glfw doesn't include Vulcan. But sure, let's give it a go. Comment that out. That means I don't need to expose native stuff, which is always nice. And that's it to create a surface, I guess. And we need to destroy it as well. Before the instance. Surface. Yeah, so it takes the instance, the surface, and I don't have an allocator set up. Querying for presentation support. Yeah, we're gonna have to do that. I think it's pretty clear that Peter is not the graphics god. If it wasn't clear before, yeah. No appropriate default constructor. Yeah, of course. Yeah, so we need to query the percent feature or whatever it is. I guess we'll see if I need this. It's not a big deal. It's not a big deal if I do. Percent family, yeah, percent family. And I assume it's very similar to this, except we don't check that, we check transfer. No, we actually need to do that, so it's not a regular thing. And we need to query it on the device itself, which, yep. Get physical device surface support. Physical device. What was it called? Surface support, not. Okay, surface support KHR. And it takes the device, the Q family index. So we need to do this here. Right, yeah, because we need to check it for each Q family. Surface, which is just that. And VK bool 32. Surface supported. Okay, but for real, I want to see the amount of game engines being made skyrocket after game in the series came out. Yeah, I imagine there was quite a lot more game engines being made after that came out. And I think a big reason for that was a lot of people didn't think that a single person could make a game engine, which admittedly, if you're a single person making a game engine, it's gonna take a long time and it's quite hard, but it's possible. Okay, so we have that. Good. We need to update our okay, yeah. Explicitly prefer physical devices support strong and presentation in the same queue for improved performance, which we presumably want to do. The one thing that remains is modifying the logical device creation procedure to create the presentation queue and retrieve the VKQ handle. Yep. I think making the game engine itself is pretty easy. The editor stuff is what takes time. Yeah, and making it capable enough to where you could actually create a game with it. Are you gonna upload this to GitHub somewhere? Yes, I am. I'm gonna upload it to my own GitHub. Just github.com/peter1745. Put it in chat. I have created the repository already, but it's currently private just because there's nothing there. And I'm definitely gonna make the main branch protected as well, because I don't want other people kind of committing a bunch of useless shit to my game engine. Right, so we need to actually set this up. So we have the %q. So okay, unique Q families. Okay, so just automating the device Q create info thing a bit. Guide Broso. I mean, there are more than enough valid game engines in the market. If you're running solo and want to develop a game, I would just suggest using an already existing engine rather than making one. Yeah, but like, you shouldn't make a game engine unless you need a highly specific feature set for your game that no other engine provides, which is hard to find. Or like, if you just want to make a game engine, then make a game engine. So where do we have it up here. Okay, so create a vector of that. I don't see a reason why it would do that. I mean, okay, no, because the code is going to be identical. So you may want something like it. You could set up a method to do that for you, though, instead of creating a brand new set. I want to make games, but I'm not touching Unity if I don't get paid to do so. Yeah. I'm just going to have an array. I'm not going to... Why would I use... Like, I know how many Q families I have. I don't need it to be dynamic. Q family array. Graphics. %. Does the order of those matter? Probably not. Q priority 1, yeah, we may as well do that. And do 4 uint32t Q family, sure, in Q family array. You only need 1 Q. What? Yeah, but isn't it just safer to have both? Because okay, no, yeah, because obviously yeah, that's pretty much always the case. Graphics and presentation, they kind of go hand in hand. Safe to assume you can present on a queue that can do graphics. Yeah. So, I mean, in that case, we kind of don't need this because they're pretty much always going to be the same. Which also means the graphics queue and the present queue are going to be the exact same handle. So, okay, we can go with that. Just call it graphics queue. Say that, because if that's the case, then I'm not gonna have like a loop for now. If I need like a compute queue, I'll set that up then. So in that case, what we can actually do is, if we want to be safe about it, which I do like being safe, what is there in human DNA that compels us all to make our own game engines? Damn good question. So in this case, what we could do is we could say if this and surface supported, just to be safe. So if it's a graphics, if it's capable of graphics and it supports the surface, just do that. Which means we only need one queue. Cool. And queue count would still be 1, I think, because we only have 1 queue. What are you using as the graphics backend? I am using Vulcan. Well, I'm learning Vulcan. Okay, so that's pointless. Good to know. I mean, this is Vulcan. This is actual Vulcan code. Or are you talking about Hazel now? Because Hazel also uses Vulcan. Yeah, this is all Vulcan code. Okay. Swap chains. But I definitely want to check this code first. I was more interested to see what abstraction you made. Currently, no abstraction. Because I literally started this today. So I haven't done any real abstraction yet. I will though, because I do want to support like Direct 3D eventually. But I do want a Vulkan renderer before I actually go and do that. So let's see if this works. The queues should be released with the logical device, right? Yeah, I think so. Once you get triangle running, then abstract. Yeah, pretty much. Like, you don't want to just start writing an abstraction immediately. Like, I'm willing to put unrelated, well, sort of, I'm willing to put a lot of code into a single file, even if they're not related, when I'm just setting it up. Because I want to have something that I can sort of compare with once I have an abstraction. Okay, yeah, whatever. Create the instance. Sure. Surface. Yes, we have a surface. Nice. So we get the physical device count, which, yep. Some really obvious ones you should abstract slightly from the beginning. Yeah, like obviously I'm going to create like a Vulkan context file. I'm going to create a Vulkan swap chain file. But like again, in Windows window, I'm literally storing a Vulkan context. I'm just not storing like, I'm not storing like an, okay, I didn't want to do that, but sure, whatever, skip all of my desire to breakpoint. And no validation errors, so it's fine. Like I'm storing a Vulkan context, not like a general graphics context or anything. Okay, so this code works, I guess. How do shaders work in Vulkan? Very, like it's, in terms of the shader code, from what I can tell, it's similar to OpenGL because it's still GLSL. It's just they've improved it a bit, and yeah, you would most likely use SPIR-V. Well, you kind of have to use SPIR-V, I think, to compile the code and that kind of stuff. But I don't know exactly how they work, like in terms of how you set them up in C++, because I haven't done that. Okay, swap chain. What time is it? Ooh. I wonder if I'm gonna end the stream here and continue tomorrow, because it's getting kind of late. Yes, I'm using C++20. Do you actually have to think about memory allocation and stuff while creating an engine? you should, but like it's not something that I'm thinking about constantly. I do sort of think about it whenever I'm doing something that is actually related to memory allocation, right? So try to keep things on the stack if possible. Use, you know, smart pointers and that kind of stuff. I once read that Vulcan is not really a graphics API, but a graphics card API that you use to build a graphics API. That doesn't sound right to me. Because, I mean, in some sense, yes, because you don't necessarily need any kind of rendering if you're using Vulcan. You can just have like a compute. You can only you can make it so you can only like run compute shaders and not actually render anything, like to a surface or anything like that. But I definitely would consider it like a graphics API, not a graphics card API per se. You know what? I'm actually kind of happy with where this is right now. It's a graphics API, yeah. Yeah, it's a graphics API that supports compute only. The main purpose is for it to be like a graphics API, though. Will Fusion be able to run crypto mining compute shader stuff? No. Fuck cryptocurrencies. I hate those. Like, I understand the idea behind them, but it's the same kind of deal with NFTs. Like, I just... no. Okay. Time to actually commit some stuff. Add a remake file. Git push. Hopefully, just works. Nice. Yeah, like I'm not personally a fan of crypto at all, but like I get the idea behind it. It's a decentralized system and everything like that. I should set up a git ignore before I do this, because there's a lot of stuff that I do not want to commit. So files, directories. So I don't want .vs. I don't want build. I don't want any solution files. No. V6 proj. No user. And no filter. Hydrate. The vendor folder, we're gonna push scripts, yes. Pre-make files, yes. I think that's all of the stuff that I want to have there for now. Yes. Yes. What are the Lua files for? They are pre-make files. Pre-make is basically a meta build system. It lets you write, basically it lets you generate projects for different IDEs and different kind of build systems in a nice way. So it's kind of like CMake, I think. CMake is about the closest. Yeah, I think it's a lot like CMake, but it's Lua and not some garbage language that was invented 50 years ago. But yeah, so I'm gonna go ahead and say that's everything. Let's do commit. Initial work on Vulcan implementation. Yeah, it's CMake but better. Let's see that we're not pushing some bullshit that we shouldn't be pushing. We're not good. Keep push. Okay. And I'm actually gonna go ahead and make this public while I'm at it. Make public. There we go, and let's see about branch protection. Oh. Vagosino, thank you so much for following. How do I protect the main branch? GitHub. Protect main branch. Settings branches, protect branch, and select. Okay. Sure. No, don't want to do that. Okay. So I believe the main branch should now be protected. So yeah. Metaverse systems are always a nightmare, but I'll check Prima out. It looks interesting. By interesting, I mean different than CMake. Are you building the engine for people to use, or just just as a personal project? It's a personal project. Like, if people want to use it, I'll be happy with it. But it's actually a personal project. And yeah, I definitely recommend checking out Premake because I like it. I haven't had any serious problems with it. Like, I've had problems with it, definitely, but everything's been pretty good, actually. So yeah, I'm probably gonna stream tomorrow as well, working on this, because I'm super excited working on Vulcan, with Vulcan, rather. It seems a lot of people actually really enjoyed watching it, shockingly. I don't think I've had this many viewers since Let 'Em Dare. So, cool. But yeah, I'm gonna go ahead and end here. Wanted, thank you so much for following. So yeah, gonna go ahead and end here. I'll stream again tomorrow. Yes, you need to suffer more. Yep, you're correct about that. But yeah, thank you so much for watching. Hopefully you enjoyed. And yeah, see you tomorrow. Bye bye.